Have you ever considered whether we are truly the only ones in the universe? Or beyond what we do, is there more to our existence? The James Webb Telescope finally demonstrates that we reside within a vast, mysterious cosmos. Join us as we learn more about black holes and the revolutionary information that will make you reevaluate your assumptions about the universe. So, what exactly are black holes like? Something from a nightmare, undoubtedly. You may have seen them in science fiction films, but the reality is even scarier. Scientists say that they're not just pitch black holes in space. They are actually a great deal of substance squeezed into a very limited space. Think of a star 10 times more massive than the Sun, compressed into an area the size of New York City. The gravitational pull exerts so much force that nothing, not even light, can escape from it. Black holes have captivated scientists for centuries as they pondered objects in space so massive and dense that they could entrap light. One of the most famous ideas about black holes comes from Einstein's predictions in his general relativity theory. When a huge star dies, it leaves behind a tiny, dense core with a mass more than 3 times that of the Sun. The intense gravity of this core sweeps everything away, resulting in the formation of a black hole. Detecting black holes is no easy task because they do not produce any light. However, scientists have found ways to infer their presence by observing their effects on nearby objects. For example, if a cloud of interstellar matter passes near a black hole, the black hole will pull that matter toward it in a process called accretion. Additionally, when a normal star approaches a black hole too closely, it can be torn apart, releasing X-rays as a consequence. Black holes also have a significant influence on the environment around them. They can consume nearby stars, emit powerful bursts of gamma radiation, and even influence the formation of new stars in some regions while delaying it in others. But where do black holes come from? Stars that were once magnificent and fiery meet their spectacular demise in an explosion called a supernova. From the remains of these fallen giants, black holes form. Most black holes originate from massive stars that have reached the end of their life cycle. Smaller stars, when they die, turn into neutron stars, superdense objects that are not quite massive enough to trap light. However, if the mass of a dying star is about 3 times greater than our Sun, it collapses under its own weight, forming a black hole due to the force of gravity. As these mighty stars collapse, strange things happen near their surface. Time itself begins to behave differently. From the perspective of an observer far away, time appears to slow down near the event horizon, the final boundary for anything falling into a black hole. Sometimes, when 2 smaller black holes collide, they merge into an even larger and more terrifying black hole. If a black hole merges with a neutron star, it creates a colossal cosmic nightmare that defies comprehension. Scientists have been studying these enormous celestial phenomena for a long time. Black holes come in 2 general sizes, small and huge. There is a sinister mystery about them that we still can't seem to unravel. Stellar mass black holes, which result from massive star remnants, can be as large as 10 to 24 times the Sun's mass. In the Milky Way alone, there may be as many as 1 billion of them, an astronomical number. Anything that drifts too close can be swallowed by a black hole. But there's more. At the other end of the spectrum are supermassive black holes, thousands or even billions of times larger than our Sun. They exist at the center of massive galaxies, including our own Milky Way. These enormous cosmic voids shape the very structure of the universe, pulling everything around them with their immense gravity. The renowned physicist Stephen Hawking dedicated much of his life to studying black holes. His lectures provided groundbreaking insights, though some of his theories remain unconfirmed due to technological limitations. However, there is hope. One scientific instrument is changing everything. The James Webb Space Telescope, JWST. The JWST is not just any telescope. It is a marvel of engineering and a testament to human ambition. While previous space telescopes like Hubble have served us well, the JWST is in a class of its own. In fact, the Hubble now seems like a mere speck in comparison. The cost of this astronomical wonder? A staggering $10 billion. Yes, you heard that right. It took the combined efforts of NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities, to bring this masterpiece to life. However, such an ambitious project also carries significant risks. The JWST is not for the faint of heart. It is a leap into the unknown, pushing the boundaries of our understanding and taking us to places we never imagined. After a successful launch, NASA announced that the telescope has enough fuel to operate for more than double its minimum expected mission lifespan of 10 years. Since its launch, the JWST has achieved incredible milestones. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully unfolded its massive 5-layer sunshield and its large primary mirror, both of which had to be folded to fit onto the launch vehicle. Now, after NASA has fine-tuned and calibrated it, the JWST is nearing full operational capacity. One of the most exciting moments came when NASA announced that the telescope had captured its first image of starlight. The initial photo of the star HD 8446 revealed 18 scattered bright dots, each reflecting light absorbed by the 18 segments of the telescope's primary mirror. Later, NASA released a refined image in which these 18 unfocused copies of the star were aligned into a precise hexagonal formation. Once the observatory successfully synchronizes its mirror segments, it will initiate an image stacking process, combining the 18 images into a single, sharp view. With its advanced technology, the JWST will help scientists unlock the mysteries of the universe, allowing us to see deeper into space than ever before. The early stages of the universe after the Big Bang will be studied to understand what happened after the first stars formed, a period known as the Renaissance epoch. This era refers to when neutral hydrogen was reionized, or given an electric charge again, by radiation from these first stars. This means going back in time billions of years, which is only possible with a powerful telescope like the James Webb Space Telescope, JWST. The telescope will also help scientists discover exoplanets, which are very difficult to spot because of the way they interact with their host stars. Strong sensors will be able to examine these planets in greater detail, including, in some cases, imaging their atmospheres. Understanding planetary atmospheres and formation conditions might help scientists determine whether or not some planets are habitable. Apart from studying the assembly of galaxies, scientists analyze galaxies to examine the organization of matter on an enormous scale. This, in turn, enables us to see how the universe evolved, from different shapes over millions of years into the spiral and elliptical galaxies we see today. One of JWST's goals is to look back to the earliest galaxies to better understand their evolution. Scientists are also trying to figure out how we got the variety of galaxies that are visible today and how galaxies form and evolve. But, most importantly, the James Webb Space Telescope will help answer one of the most profound questions. Are we alone in the universe? Or are we a part of something greater? Black hole discoveries. The JWST has already been on the lookout. And guess what it discovered? Compounds called polycyclic aromatic hydrocarbons, PAHs, organic molecules, were found lurking around gigantic supermassive black holes in 3 active galaxies. These molecules, based on carbon ring-like structures, are incredibly widespread in the universe, from distant galaxies to comets in our solar system. Not only are PAHs fascinating because they could be building blocks of life, but they also help scientists study star formation. When ultraviolet radiation hits PAHs, they emit infrared light, which JWST's mid-infrared instrument, MIRI, can detect. This emission is often an indication of young, hot stars forming. However, here's the twist. A courageous astrophysicist, Ismail Garcia Bernit from Oxford University, decided to take a look at 3 active galaxies, NGC 652, NGC 731, part of the famous Stephan's Quintet, NGC 749. These galaxies are millions of light-years away in the depths of space. What Garcia Bernit discovered will send chills down your spine. In the central regions of these galaxies, where supermassive black holes reigned supreme, an abundance of PAHs was found. Sounds good, right? Well, here's where it gets chilling. The intense radiation near these black holes twisted the PAHs, expanding them into larger, electrically neutral versions of themselves. The smaller, electrically charged PAHs vanished into oblivion, as if they were being devoured by the darkness itself. However, there's a glimmer of hope. The larger patches survived by taking refuge in dense clouds of gas, shielding them from the black hole's fury. But why does this matter? Astronomers rely on pHs to track star formation. Normally, star-forming regions are filled with electrically charged pHs. If these molecules are destroyed near black hole cores, then tracking where new stars are born becomes a real challenge. But fear not. Garcia Bernit and his team are determined to dive deeper into this cosmic abyss. They plan to study more active galaxies to uncover how pHs survive in such extreme conditions. Understanding these molecular survivors could help scientists unravel the secrets of star formation and galaxy evolution over time. The oldest black hole in the universe. Another spine-chilling discovery made by JWST is what could be the oldest black hole ever detected. This cosmic monster is a supermassive black hole, weighing a staggering 10 million times the mass of the Sun. JWST identified this black hole by analyzing faint glimmers of light from 570 million years after the Big Bang. This means the black hole existed when the universe was still a baby. Astronomers are now questioning whether other ancient black holes are lurking in the darkest corners of space. The discovery has shaken the scientific community, as this black hole could be one of many that formed in the universe's earliest days, about 100 million years after the Big Bang. The black hole and dark matter connection. Scientists are baffled by how these early black holes grew to such enormous sizes. Some researchers speculate that these black holes might be linked to dark matter, the mysterious substance that makes up most of the universe's mass but remains invisible. If early black holes formed rapidly after the Big Bang, they could account for some of the missing dark matter. If proven, this could unravel one of the universe's greatest mysteries. JWST's future discoveries. The James Webb Space Telescope isn't just studying black holes. It also has the power to observe exoplanets in unprecedented detail. By analyzing the light filtering through an exoplanet's atmosphere, scientists can identify chemical signatures, like water and methane, that could hint at the possibility of life. JWST's infrared capabilities allow it to look further back in time than ever before, capturing light from the earliest galaxies and stars. This helps researchers understand galaxy formation and evolution, providing insights into the conditions that shape the universe. As we push the boundaries of our knowledge, the interplay between black holes and the structure of the universe remains an enticing mystery. Each new discovery brings us closer to understanding the true nature of the cosmos, a universe far more complex and awe-inspiring than we ever imagined.